Welcome to lesson number 7, Learn C Programming on the Raspberry Pi. Okay, we're going to continue on with our discussion of functions, but just before we do that, I want to go over some of the commands, Linux commands, and some of the C language terms that we've used so far. I have a list here, so you may want to review cat command, cd command, gcc command, genie command, ldd command, ls command, mkdir, and wc. And sometimes you'll also notice that I use a command called grep, which is basically search for strings in a file. So if you want to find information in a file, you can use the grep command to do that. The C language terms that we started to use were compile. Of course, you should know what that means. Is that basically take the source code, which is in human readable form, and to compile it and build it into machine language or machine code, something that the computer understands. I also use the word library a lot. You'll notice that by default C uses the standard C library, but we also looked at the math library, and there are dozens and dozens, if not hundreds, of other libraries available for the C language. Once we get into actually using the Raspberry Pi to control devices, you'll see that we'll start using specific libraries for the Raspberry Pi. Another term we learned was the call by value, which is how C handles parameters or arguments being passed from the calling program to the program that's called, or I should say function, from the function, the calling function, to the called function. A program, by the way, is just a collection of functions, so I don't want that to be too confusing for you. I also mentioned the word actual parameter or argument. This is the actual parameter or argument that you give to the calling function. And the formal parameter is the one you specify on the definition of the function or on the function prototype. So the function prototype is basically just a one-liner that kind of defines the heading of the function. And the return value, of course, is the value that the function can return. Now, when we look at operators for the C language, of course, we've been using the plus operator, which means to add numbers together using a plus sign. But we also use the ampersand here. It's the address of, I guess we should put that in quotes here. And we've used that operator in the scanf function. Of course, the thing about C is that some of the operators have two or more meanings, so we'll get to other meanings for these operators a little bit later on. Okay, so these are the things, the words and commands that you should experiment with, play with, read about. If you have a book on C, you should go to the index and look up some of these terms and read about them. And okay, so let's go on with lesson 7. First of all, I'll go over to the Raspberry Pi. And here's what we have so far. If I look at the lessons directory, you see I have lesson 1 through lesson 6. So today we're going to be working on lesson 7. So the first thing I'll do is I will start Genie in the background. And you notice this ampersand here, this is a command for the Linux operating system. It's not a command for the C language. So it's a little bit confusing, I guess. Anyway, we'll start up Genie and we'll look at what we did last day before we can add to it and move on. So the example we used last day was this inches to centimeters function. So here at the top, this is the prototype. This is the function prototype. It basically tells the compiler the return value. It tells the compiler the name of the function, and it tells the compiler how many and what type each parameter is. In this case, we have one parameter and its type is a float. And the name of our function is into_cm, and it returns a single float item. Okay, so here's our main function. Our main function, we define two variables, in, which is a float variable, and cm, which is a float variable. And the first thing we do is we print out just a string. Nothing fancy. We print out a string, enter the number of inches to convert to centimeters. And then we have the scanf function to scan in a float. And where do we put that float when we scan it in? We put it in the address of this variable called in. Okay, so once we do the scanf, once we accept from the keyboard the value of inches, then we can move on to the next line. Well, to execute this next line, we have to do a call to this function. So the main program calls this function. But before that function can execute, in other words, before we can do all of these statements in the function, this actual parameter has to be copied to this formal parameter. So whatever we entered on the keyboard for the number of inches, that has to be copied to the formal parameter we call x. And this mechanism is known as call by value. So C uses call by value to pass parameters. So once the parameter has been passed from actual to formal, then this function takes over and it runs. Remember, in C, unless you're using multi-programming or you have more than one function running kind of concurrently, then normally you just have one function running at a time. So here in this case we have this function is now running. So it declares a float, a result, and it multiplies x times 2.54 and it puts it into result, and it then returns result. What do we mean by return result? Well, return result means that when this function is completed, the return value is put in this spot. So whatever this guy returned, it's placed up here on line 9, and then it's given to cm. So the return value is replaced on this line. And then of course we print the inches and the number of centimeters, and then we return to the operating system, return back to Linux. Okay, so let's just run this guy again. I think it's probably already built, so we'll just execute it and See if that works. So it's now stopped on the scanf function here, waiting for me to type something in at the keyboard. So if I type in 12 inches and I hit enter, then it says 12 inches is 30.48 centimeters. Okay, so that's how that works. So let's now move on a little more detail on this call by value, see how it works. We'll start another program here. Close that one. I'll close that one, and I'll start a new one here. And okay, I'm going to create a function here. I'm going to put a prototype in here for a function. Then I'm just going to pass one integer to it. And I'll say int, let's say x equals 3. And then I'll say do it x printf is value of x is x, and return 0, and that's our main. So now I'll write the code for do it. And I'll call this the formal parameter. I'll call it y. I could call it x. Pardon me. I could call it x or anything else I want, but I'll call it y. And so now I'll say printf y is %d / end quote comma y, and then I'll say y equals y plus 1, and then I'll just take this code and copy it again right here, and that's the end of my function. Okay, so I'll save this guy, save as, and I have to remember to put it into lesson07. So I'll create a folder, and I'll say lesson-07, and I'll call it I don't know, I'll call it just call it fun.c. Okay, so there we have. So let's look, before we actually compile and run this guy, let's see what he's going to do. Here's our prototype for the function. The prototype, remember, has the name of the function, has the return value. You notice this time we don't return any value. And it has a single integer as the one and only one parameter or argument. Main starts right here. It creates an integer x and initializes it to 3. Then it calls the function do it. So do it will then copy x to y. Remember that C uses call by value. So 3 is copied to y. So this first print here should print out the value of y is 3. Then of course do it will increase the value of y by 1, and then it will print out the value of y is 4. And then do it will complete. Once do it completes, then this printf will work, and it will print out the value of x. And what do you think that value will be? Well, let's try it. First we'll see if it compiles. It looks okay. So now we will execute it. And this is what we get. So the very first printout, the value of y is 3. That's right. The second one, the value of y is 4. That's this line here. And then when we return back, it says the value of x is 3. So you notice that the value of x did not change. Well, we changed the copy that we made. Remember that we made a copy of x when we made the call. So this copy was made, and then we increased the value of the copy, but once do it completed, that copy was lost. So we're back to having the original value of x, which is 3. Okay. So this really shows how call by value works. Well, let's suppose that we wanted to have the value of x to be different in the main program. In other words, we wanted to get some information back to main. Well, then we'd have to do something a little bit different. And let me show you what that is. First of all, I'm going to change this prototype, and I'm going to put an asterisk in here. And I'll explain what that means in a bit. And then what I'm going to do is I'm going to call do it with the value or the address of x. And since the prototype here has an asterisk here, I'm going to put an asterisk up there. And then I'm going to change these guys like this. I know it seems very, very awkward, but unfortunately, that's the way C works. One more change here. And okay, so I'll go through this line by line, but first let's just see if we have a program here that works. I'll save it, and I'll try to build it. And it did compile correctly. So now I will run it. In fact, what I'll do is I think I'll run it on the command line. There I have the program fun.c. So I'll go gcc.c -o fun. Okay, so I've compiled it. Now I can run it by doing this. Now you see what happened now is that the value of y is 3. This is the first print statement. Then it increases the value of y by 1, and it prints out the value of y is 4. And then when do it completes, then it returns back to the calling function, and it prints out the value of x is x, which is 4. So it really changed the value. The value of x was changed inside the function doIt. But look at all of the syntax here. It just looks so bizarre. But once you get used to it, it's not too bad. So let's go over this very gently and see what it means. The first thing is we've introduced this asterisk here, and in this context, what it means is it's a pointer to an integer. Let me bring up this little list I have of commands, and I'll add that in down here. Means pointer to, and the other thing is the asterisk has other meanings as well. Like, for example, the asterisk also means to multiply, but that's a different context. Okay. In this context, it means pointer to or pointing to. So what I'm saying here is that my argument here is not an integer. It's actually a pointer to where an integer is in memory. This is saying it's a pointer to an integer. So what is y here? Y, as the formal parameter, is a pointer to an integer. It points to an integer, where an integer is in the computer's RAM, random access memory. So since we're using a formal parameter here as a pointer to an integer, then our actual parameter must be the address of where the integer is. So we start off with x is 3. So x occupies a place in RAM. So x must have an address. Well, we pass that address. This address is copied to y. The address is copied to y. So this time we're not passing the value of x. We're not copying the value of x to y. We are copying the address of x to y. So it still uses call by value mechanism. The difference is that we're not copying the value of x to y. Instead, we are copying the address of x to y. So we're copying an address, a computer's address. Well, now that we know the address of where x is sitting, this printf statement, he says the value of y is, and it says the whatever y is pointing to. That's the value of y. Well, y is pointing to this x, since y is the address of x. So then we say, okay, this line looks kind of strange, but what we're saying here is that the value at that address, we want to increment that value at that address by 1. So doIt, you can think of it as reaching outside of itself, going to main and changing the value of x because it knows the address. If you know the address of where it is, you can change its value. So once you change its value, the new value is here, is now a 4. And when we come back and we print out the value of x is x, we notice that x is now changed to a 4. So let me repeat that again. The doIt function, it receives the address of where x is stored in RAM, and it manipulates that integer that's stored at that address using this statement. So what's important here is to know is that call by value is call by value. Sometimes we copy an integer to an integer. Sometimes we copy a float to a float. Sometimes we copy a character to a character. But in this case, we are copying an address to an address. You know, you can think of it this way. When you buy a computer, the computer has so much RAM. For example, 8 gigabytes or 16 gigabytes. Well, every location, every byte has an address, like mailboxes in a postal station. So obviously the more RAM you have, the more variables you can have, the bigger a program you can. Okay, let's try one more thing. Since we're printing out the value of x and the value of y, and we notice that in our doIt function, y is just a pointer to x. When we change the value that's stored in location y, we are actually storing the value of x itself. But let's try printing out the actual address. So just before we call the function, we'll print out the address of x is so I just want to tell it that I'm printing out a pointer. I'm not printing out a decimal number or a float. I'm printing out a pointer. So now what I want to do is tell it I want to print out the address of x. So let's just see if we can compile this guy without any errors. So I'll save it and build. And it says compilation finished successfully. So let's now try to run it. And you can see the address of x is this hexadecimal number. Don't worry about this too much. This is just the 0x at the beginning says that what follows is a hexadecimal number. So it's in base 16, not in base 10, but that's the actual address in the computer of where x is stored. Okay, so this more or less wraps up lesson 7. Our discussion on functions, however, is not yet finished. There's still a lot more to know about them, and we will continue with them in lesson number 8.